Hey there, welcome to Grad Coach TV, where we demystify and simplify the oftentimes confusing world of academic research. My name's David, and today I'm chatting to one of our trusted coaches, Kerryn, about 6 top tips to keep in mind if you're doing descriptive analysis. So hey Kerryn, welcome back to the Coachcast. It's great to have you here. Really looking forward to today's discussion.
It's lovely to be back, David.
So Kerryn, today we're talking about some tips and advice for if you're doing descriptive analysis. And I think the first tip is a big one, and it's probably one of the most important, is just not to neglect descriptive statistics. What do you have to say about the importance of descriptive statistics?
Absolutely. It's the most important step for any statistics. Never neglect the descriptives first. And I think one of the struggles that we have is just thinking about what descriptive statistics can do for us. And for a lot of data scientists and statisticians and researchers, they use descriptive statistics within the exploratory space, so in exploratory data analysis. And so if we think about what that is, it's kind of just exploring your data, figuring out what it looks like, just to have a familiarity with what your data looks like, to have some certainty with how you can describe it and understand it, and just making sure that you're on top of your data. And if we sort of just jump this step and we go straight into testing hypotheses and the inferential statistics, we could be losing key information that we just didn't even know existed because we didn't look at the data, we didn't look at it in some detail, and we didn't explore it first. I think generally speaking, what we're wanting to think about is why exploratory data analysis and descriptive statistics can be useful for us, and can be useful for a number of reasons. Firstly, they can tell us what analyses are appropriate for our inferential tests, for testing our hypotheses. Because if your data looks a certain way, some tests might be more appropriate and some tests might be less appropriate. And we don't need to go into many details here, but knowing the assumptions behind the tests that you're putting in can only really be fully understood if we explore the data first. The second reason is to sort of understand whether the data that we have is appropriate. A good example of where this might break down is if we don't have large enough sample sizes for the groups that we're wanting to compare. Maybe our sample as a whole looks pretty rad. We have like 3,000 individuals, but the group that we're interested in only has 15 individuals, which does mean that we have to reconsider maybe even getting more data. So knowing that your data is appropriate is another good reason for exploring it first. And then, of course, finally, we just want to know what's happening. We tend to just want to jump in it and then we get overwhelmed because we've got so much data. But some of the important things about exploring your data, understanding your data, is just looking at it variable by variable, question by question, column by column, and just seeing, what does it look like? Can I use this? Can I explain this? Oh, that's interesting. And so just for those various reasons, exploratory data analysis is probably the most important step. And for many people, it might even stop there. You might not even need to do inferential statistics, but for a lot of people, they might use the outcomes in order to fully understand and embrace the outcomes of their inferentials as well.
That's very useful. Another bit of advice is to just keep doing descriptive analysis as you go. It's very easy to think you have to have all of your data together to know, all right, now I can go ahead with the analysis. But if you're collecting data as you go, you can assess, you can find out if you've got too little people in your treatment group, if halfway through your data collection, that can be really beneficial. Or maybe if you do a pilot, you can analyze the pilot data first before going all out into your full study. And that's just going to help you catch any issues early on. So our second tip, and it's a great one to think about really early in the process, is to know your data type. Kerryn, why do we want to think about what type of data we have before we dive into the descriptive analysis?
Absolutely, knowing your data type is incredibly important because if you know the type of data that you have, you will know how to describe it or how to explore it as appropriately as possible. So the good news is there's only really 3 types of data that you can have. So that does make things a bit easier because you can kind of just think, okay, well, which one of these does each variable belong to? In some programs, they might even ask you for this information before you can even do some analyses. So that's helpful. It's a helpful first start. First kind of data that you might get is categorical data. These are counts or frequencies of something. So you'll tend to have people who've selected their favorite color as blue and people who've selected their favorite color as red, where the categories, categorical data, are red and blue. The kinds of ways in which you will display this information is through, for instance, bar charts, where you will have the height or the number of people who selected blue and compared with the height and the number of people who selected red, and you can kind of see which group got the most participants scoring positively on them. So that's one way to sort of just represent that data. When you're writing about this data, you will then talk about the frequencies and ideally the proportions. So you'll say something like the sample consisted of 28 blue color lovers with the percentage next to it, and 29 red color lovers, and you'll put the percentage next to it. Another really useful or another category, another type of data is numeric or scale data. Numeric or scale data exists on a number platform where you can easily sort of, see what the number is. A good example of this is height, where you can be 112 centimeters tall, or you could be 256 centimeters tall, and it exists on a spectrum. So numeric or scale data, typically we use histograms in order to show the spread, to show the shape of the overall data. And if we wanted to compare groups, we might use something like a box plot to compare the different, groups and their variation next to each other. When we write about it, we will talk about both the average on average and the standard deviation. So we'll say, for instance, the average height in the sample was 172 centimeters, and then in brackets, standard deviation equals 36 centimeters, just as an example. A final category is that of ordinal data. And ordinal data doesn't fit comfortably into either of these because it's not quite numeric, it's not quite like height, but it's not quite categorical. Instead, what you have is an order, options that need to be in a specific order, but are not necessarily similarly divided, if you will. So a good example of this is, to what degree do you agree with the statement? And you'll have strongly disagree as an option, which you might score as a 1, and strongly agree, which you might score as a 5. This is known as Likert scale, where you have those kinds of options that are presented in this order. And a good way to present that kind of data is through Likert diagrams. But the tricky part comes, do you treat this in other ways like categorical data, or do you treat it like numeric data? If it's fewer than 3 options, then we tend to maybe treat it a little bit more categorically. But if it's sort of 4 or more options, we tend to treat it a little bit more like numeric data.
I couldn't agree more, Kerryn. It's so helpful to think about what data we have so that we can plan how we're going to go about looking into our data, right? Once we know what our data is, we can think about what graphs we can make, what stats we can run, how we're going to write it up. And so it's really just helpful to take a break right at the start, think about each of your variables, and you can probably figure this out before you even collect your data. So definitely have a think about the type of data you have. For our third tip, we want to be talking about the importance about how visualization helps us explore the data that we have. Kerryn, I know you love visualizations, so maybe you can give us a bit of advice on how to go about doing this.
I do love visualizations. I think it's the most important thing to do when you're exploring your data. It's kind of dry when you just get given a bunch of numbers like means or averages and standard deviations. You don't really know how to interpret it. But when you see a graph, you see a graph, and you just need a little bit of knowledge usually to be able to interpret it a little bit further. I would say that visualizations are just so key to that exploration phase, not because all of this will end up in your dissertation. In fact, it's possible that very little of it's going to end up in your dissertation, but because it really gives you an opportunity to engage and understand your data in a deeper way. A good example of this is what we spoke about earlier, those histograms, where you look at the shapes of each variable before you start exploring it further, before you start doing the stats further, because then you know, ooh, people chose this option, or ooh, look at how many people are in my sample that are choosing this, or that are thinking this way, or that have high levels of anxiety, or that really don't like this topic at all. And when you start seeing that, when you start seeing how this data is distributed, it makes so much more sense, and you really get a fuller understanding. Bar charts, you can compare the different options and how many people chose the different options. The histograms can show you the shape of those variables. It can tell you who the majority of your respondents in your survey are, or whether your intervention has improved, whether the scores are higher or not, how they compare. Maps can also be used as visualizations. In fact, they should be used as visualizations, especially if you feel that there's some kind of variability in space that you might want to look at, maybe differences between countries or provinces, or even just geographically across biomes if you're a biologist. Of course, graphs rarely tell you just what your data looks like, and can also tell you if something is off. So if, for instance, you have a scatter plot and you have this rogue individual point somewhere in the middle of nowhere, then you've got something to ask. Is this an outlier? Is this an individual I need to delete? Do I need to go back into the data and maybe correct something? Being able to see that just gives you a bit of sense as to what might end up being picked up perhaps by your tests. For instance, the average might be skewed by that outlier, but you might not have known if you didn't just look at the data. Very importantly, graphs are mostly intuitive. Quite often you can just see the data and you can see what it looks like. Of course, don't go down the rabbit hole and look for patterns that don't exist. That's why you do have these statistics that can help you really see if these patterns are meaningful. But to really get a sense and understanding of the patterns that exist in your data, do a few graphs, do hundreds of graphs. Remember, not everything will end up in your dissertation. Some, like box plots, might need a little bit more understanding and intuition before you sort of delve into them. But once you do understand them, they can be super powerful and very intuitive moving forward.
To add to that point, sometimes it can be really helpful to look at multiple variables together as well. I'm a regression guy, so I really like to look at how two variables are working together and how patterns are arising in the data. And sure, sometimes you'll come up with a really great figure, and that's going to go right into your thesis. So don't think that doing this visualization is unnecessary, because you're going to identify patterns you might not have identified before. And the worst case scenario, you've got a few potential graphs that you can implement in your appendix or in your write-up itself. So our fourth tip is one that comes up pretty often, and that's variation and shape of your data is just as important as the central tendencies. So how it looks is as important as what your middle value is. Kerryn, why is it so important to consider all of these factors about our data rather than the mean, so to speak?
I think there's a lot of reasons for that. I think the mean is very useful. The average is very useful. I use it all the time. It's a great statistic to just look at and see whether there's differences or what the patterns are. But the issue lies when people leave it there. And then it's like, oh, this is the average, we're done with it. But sometimes that's not really where the interesting stuff lies. Not to mention the fact that mean and median, as they're very useful, makes a few assumptions around the data. We assume that everyone's behaving, or the majority of the sample should behave like the mean or the median, or that this is the normal experience, when in reality, that's not. People exist on a spectrum when it comes to how they answer surveys, how they exist in reality. Animals exist on a spectrum in terms of reality. And sometimes it's important to know what that spectrum is, what it looks like. And generally speaking, we think about a few things in this context. We think about the variation. That's when things like standard deviation come in. If the standard deviation is wider in one sample or in one variable than in other, then that can mean that things are changing or things are more uncertain for a certain variable or certain experience, or that population is undergoing a lot of factors that might be influencing it more than maybe another population. So standard deviation does tell us information. even though it might be slightly different from the information we get from the median or the mean. We can also see what the shape of the data is. A really good example of that is we tend to assume that a lot of our data, especially we're talking about numeric data in this instance, is normally distributed. That means that if we sort of line it up, it will sort of form a bell curve where the majority of people, individuals, will be roughly around that mean or that average point. But that's not what a lot of data looks like. Quite often data is quite skewed. A really good example of this is income. A lot of more people are poor than are very rich. So income is very skewed towards more poor people. And we can also see, for instance, bimodal distributions. A really good example of that is height in a population. We spoke about height before, and height for a single sex might be normally distributed, like males or females. But as a population, you'll have two peaks because of males being taller, generally speaking, than females. They, of course, are going to overlap, but those peaks are what makes it bimodal. And as soon as we sort of understand that there's a shape that might be useful or interesting, we can start really thinking about our data in very exciting terms. What if, for instance, over COVID, you found that there is a bimodal distribution in well-being? Wouldn't you want to go explore that? Wouldn't you want to see, are the people who have greater levels of well-being in that first peak more likely to be males or females, more likely to be older or younger, more likely to work in certain professions than others? As soon as you can see what the shape looks like, you can explore it. And you can't do that if you're only looking at the mean. If you have more than one variable, we tend to also want to sort of compare those in some way, and we make assumptions often about the variables together forming a linear or straight line shape. But until you sort of see that, and until you know the different shapes of the different variables themselves, you might not be able to understand if it maybe created a little bit of a curve instead, or maybe it's just a little bit more messy than you initially interpreted. So understanding the shape, understanding the variation is just as important, and sometimes can actually tell you some really interesting, insightful information that you won't just get if you just look for the average and are done with it.
That's very true. And I think one thing that comes up is because sometimes it's not as cool to talk about skewness and kurtosis. These are really boring words, but they really do underpin a lot of what we do in descriptive analysis. And if you're taking your results further into inferential space, they're really important. Most assumptions are based on these kinds of ideas of skewness, normality, distributions. Those are really core ideas that we need to understand in order to know, are we using the correct test for our data set? So our fifth tip that we're covering today is the importance of outliers and how we should actually take a look at them and explore them. Kerryn, why is it worthwhile taking a look at outliers and not just hitting that delete button?
Okay, so now firstly, of course, you can always delete your outliers, but I really strongly encourage you to not do that first, mainly because outliers themselves can be interesting, and they're interesting for a number of reasons. They're interesting because we can sort of see where inaccuracies may be coming into our data. Is it because maybe somebody was lying in their survey to us? Is it because they were just hitting strongly agree for everything? Is it because maybe we measured it incorrectly? Maybe our instruments were off if you were using instruments in your analyses or to collect your data. You would obviously be able to see some outliers and try to think, oh, well, what was going on here? Of course, that giant 6-meter tall person in your sample, you would have probably noticed when you were collecting your data. So you can sort of really go back and maybe you'll delete them, but maybe you want to interrogate them. Is the correct data maybe stored somewhere else? Maybe, for instance, if you didn't record directly onto your spreadsheet, maybe you'd written the values down. You can go back into that person's value sheet and sort of see what the correct data is. So exploring and understanding your outliers is actually really important for just that one reason, because you can possibly correct the data, or you know why it is that you're deleting that individual. However, I do want to also point out that outliers do exist naturally. We do have people who are incredibly tall, maybe not 6 meters, but we do have very tall people in our populations. Humans do have extraordinary outliers. That's where all those people who go and perform at the Olympics, they're all outliers, I assure you. And if you just hit delete, you would be missing out on really interesting and important information that could be further explored, that could be telling you something a little bit more. A really good example is if you're trying to understand what might be causing dissatisfaction at your work, and you get one person who's super dissatisfied in his job, that's the person who you're probably wanting to understand, not all the happy people in the corner. And so as soon as we start understanding who these outliers are, asking ourselves, is this because of an error from our side, from the collecting side? Is it because of a misunderstanding or a lie from their side? Or is this real? Then we can really start unpacking and understanding our data at a different level.
That's really sound advice. And I can just really iterate the importance of this. I remember in my master's, I was looking at, and the stories come up before, but that I was looking at species distributions of different animals. And I had a bird in my data set that had a species distribution that was more than 7 times around the world. Obviously, that was an issue. And it turned out it was a misplaced comma, or a decimal. And so if I hadn't looked at that data, done that exploratory analysis, that could have got through. Fortunately, my supervisor and I did take a look at that data, we noticed it and realized, oh, wait, I went back to where I got my data and said, oh, that was just an error when I was typing it up. And so outliers, definitely important to take a look at. So our 6th and final tip is really more important when you're putting together your final dissertation or thesis, but really we're talking about neatening up your presentation. So when we're thinking about these descriptive analyses, what are the things we need to be keeping in mind in terms of how to present it in the final dissertation?
Yes, that's exactly something that you need to consider at some point. Obviously, when it comes to exploratory data analysis and descriptive statistics, my number one encouragement is don't worry just yet. Worry about it towards the end, because you do want to use this time to explore, and not everything will make it into your final thesis. So have fun, get things wrong, practice some of these analyses, build up your intuition. However, obviously some really cool things might come about or be really important, and you do want to put them into your final dissertation, in which case you need to consider your presentation first and foremost. And I would really consider you first look and see what other kinds of graphs and tables are used by other publications and maybe even other dissertations for research similar to yours, so that you can build a sense as to what kinds of graphs, what kinds of ways of presenting this data is most appropriate for you. However, there are rules of thumb to think about. Firstly, when it comes to tables, you do want to make sure that the table is neat, that it is very easy, that you can see whether there's different, groups or groupings in the table. You need to have a lot of white space. You're wanting to make it look really clean and professional. Something to really consider is to use an existing style guide like the APA. The APA has a really nice, professional, clean look. And especially if you're thinking about creating some demographic tables, you can maybe go in and Google and see what demographic tables using the APA style look like, to just sort of build a sense as to what you might want to do or how you can do it. Another really interesting thing that you can consider is perhaps just making sure that there's a lot of white space, that the little sections are boldened, that kind of thing. When it comes to graphs, you want to still keep that energy. You want to keep it easy to interpret, a nice, clean presentation. And one thing that might help, especially if you have multiple graphs, is to rather consider consolidating them together and paneling them. So by that, I mean, instead of just having one graph and then some text, and then another graph, and then some text, put all of your graphs onto one sheet and then have your text on the other. The really useful thing about paneling is you kind of are putting them in a way that is nice and neat and kind of out of the way of the text, but also together in a way that you can sort of compare and contrast the different images. And so that can be very useful as well. My rule is that while paneling is very useful, try not to squish as much information as possible onto one graph. Rather have several graphs paneled than try to put a bunch of variables onto one graph that's hard to read, that's very messy. Try to make sure that there's maybe no more than 3 variables. So if you have a scatter plot, you've got your x-axis and your y-axis, and then maybe your colors. Those are 3 variables. And try not to have more than that, because things start getting messy very, very quickly. If you are using color, consider being as accessible as possible. One issue that tends to come out is that of color blindness. You might think that your red and green color options are very easy to distinguish, but for some people, they're actually very impossible to tease apart, and they won't know what trends you're looking at or seeing if you use those options. If you're worried, consider just going online and looking for accessible color charts that you might be able to use, or maybe even just upload your chart onto one of those online images to see if you can see what a colorblind person would see if they were looking at the chart for you. So those are some options to consider when presenting your tables and graphs.
I think that's really helpful. And one thing we want to keep in mind is, as Kerryn said, not all your graphs are going to make it in. But sometimes there's really nice information. It's just not contributing exactly to that core message you're trying to get across. In cases like that, use your appendices. They're there for extra information. There are ways that you can really engage with work a little bit further outside of the primary scope of your dissertation or thesis. Some extra advice is it doesn't count towards your word count, but do remember that it's also unlikely to be marked content in certain universities. So when we're using appendices, we're really using them for extra information, or in the case where it's additional information that is important to the narrative, but you don't need it to really understand the research question or problem. So definitely take advantage of that appendices, but don't rely on it too much.
Absolutely. The appendix can be a very powerful tool. And when it comes to any of these graphs, these tables, make sure that in text, so in your results chapter, in your methods chapter, wherever you have them, make sure that the tables and figures can stand alone. I should be able to understand it by just looking at the table or just looking at the figure. And if I can't, consider having a caption that tells me what to look for. So for instance, what the different symbols might mean, or if you have a legend that shows me the different colors and what they allude to, that can be very helpful. So make sure it's very clear to the observer what it is that they're seeing, especially if these are going into your dissertation, but even if it's just for a presentation at a conference or something. Another really important consideration in your results chapter is do not let the figures in the table stand alone. Do not say, here is a table showing my demographics. Tell me what it is that I'm looking for. Tell me what it is that I'm seeing. The text should stand alone, and the figures and the tables should be able to stand alone. And you, as the author, need to tell me what it is that I should be seeing. And for me as the reader, it should be obvious that that is what I'm seeing if I look a little bit deeper. So that's really something to consider in your final write-up.
I totally agree. It's often super helpful to your reader what the interesting finding is. When you're engaging with that demographics table in your main text, you don't necessarily have to say everything. If you've got something where your options were red and blue, you might say something along the lines of, there were 34 blue lovers in this data, making sure to say what that percentage is. And if it's clear that the other option is red, people can do the math themselves. So you no need to go all in on that data set, but definitely think about telling us what the core or interesting findings is. So look for those data points or those patterns that are more important to your narrative. Those are the ones you really want to be touching on in your text. So Kerryn, thank you so much for joining us today. It's been great having you here talking about descriptive analysis.
It's been great to be back. Thank you, David.
All right, so that pretty much wraps up this episode of Grad Coach TV. Remember, if you're looking for more information about descriptive analysis, head over to the blog at gradcoach.com/blog. There, you can also get access to our free dissertation and thesis writing mini course that'll give you all the information you need to get started with your research journey. Then don't forget, if you're looking for a helping hand with your dissertation or thesis, be sure to check out our one-on-one private coaching service, where you can work with one of our friendly coaches, just like Kerryn. For all the information and to book that free consultation, head over to gradcoach.com.